Hello guys. So today we are going to review chapter 8, the integrals, improper integral, and the other stuff. So let's start with the first question. I will use different colors during the solution. Find integral 2x cubed cosine x squared dx. So here, what we should do, we are going to use the u substitution, right guys? And since we have cosine of x squared, we can take x squared as u, okay? And then du will be 2x dx, all right? So what I did, u is x squared and derivative of both sides, let's take. And we have du is 2x dx. So how we can substitute it here? Equals, here I have 2x cubed. I know x squared is u, so that x squared will be here. And then cosine of x squared, and then it was 2x cubed, here left 2x dx. Now substitution, I know that 2x dx is du, x squared is u, and x squared is u. So I have a new integral with new variable, which is u cosine u du. Okay. I applied u substitution, I got this one, but here u is a function of x generally, right? So we have u and cosine u. I have to apply integral by parts, okay? So, so u v du. But here, since I already have u, I choose, let's say it's w, okay? So w is u, a new variable. In this case, I will have dw is du, okay? And if u is w, then dv is cosine u du. In this case, what is the v? Cosine u, if cosine u du, that will be sine u, okay? There's a question, what happened to x in 2x cubed? So guys, 2x cubed is here. So 2x cubed, x squared is here, and 2x here. 2x times x squared, okay? I just split that because I have 2x here, 2x I use with dx, okay? Here it is, it's du, and x squared is u. At the beginning, it's here. I think it's great. X squared times 2x is 2x cubed. And then we have this. Here we apply integral by parts. So instead of v, I use w. And w, if dv is cosine u, yes, I think it's correct. So what do we have? Equals now. uv, so we have uv, okay? That is w sine u. W sine u minus v du, right? V du. So I have sine u du, okay? All right, I know what is w, it is u. So I know what is u, but I have to calculate this integral here, the second one. By the way, I can write w sine u. W is u, u is x squared. So that is x squared sine u sine x squared minus So integral of sine u is what, guys? It is the cosine u, okay? It's, by the way, minus, right, guys? Here, so I should have plus here. Plus cosine, I write it as u plus c. So the final answer is x squared sine x squared plus cosine x squared plus c. Yes, this will be the answer. Let's check with the solutions. Yes, it is. Any question here? Any question? Please copy the board and let me know when you are ready. So the second question, find the indefinite integral sine square 7x dx. We have a u substitution here again, right? Okay, so here we have u equals 7x, and then du will be equal to 7 dx. How do I write my question? My question will be in the form, so the integral sine square u, guys, as you see, dx here, it's du over 7. That over 7, I write in front of the integral, so I have sine square u du. Okay, so how do I solve this? Sine square du. When it is sine, it's fine, but when we have a power, we have to use some trigonometric formulas, as you remember, right? And what are those formulas here? Where we have sine square u, we should have cosine or sine, whatever, but without any power, okay? It will be helpful. Remember that. And by the way, you can prepare your index cards and you can use during the test next week. And what we know here, we know sine 2x is 2 sine x cosine x. It doesn't help us. It's right here what we know. Sine 2x is 2 sine x cosine x. It's good, but here I need something with squared, right? Where do I have sine squared? What was cosine 2x, guys? Cosine 2x is 1 minus 2 sine square x, okay? If cosine x is 1 minus 2 sine squared x. So from here, what is sine square x? That is 1 minus cosine 2x all over 2. 1 minus cosine 2x all over 2. Okay. And here, I write question again. So 1 over 7, but I have u, of course. So I will have 1 minus cosine 2u over 2 du. I have 1 and minus. So I write it like 1 over 7 integral 1 over u du minus 1 over 7 integral. Actually, I have here 2, I would write 14. Yes, guys? Okay, I do it next step. So 1 over 7 cosine 2u du over 2. All right. And here, okay, this one is okay. Well, let's continue. 1 over 14 du, 1 over 14 du, and minus, that will be 1 over 14 again, cosine 2u du. And what do we have here? Cosine 2u du. I have to use u substitution. Yes, guys. Again. So that is my function cosine of 2u. And u substitution we say, so since it is u, let's say take it as v. If v is 2u, dv will be 2 du. Yes, guys? And equals, so, all right. Guys, what will be this one? So there it's 1, so integral of 1, it is u, right? So I have u over 14 from the first integral, it comes. And from the second one, minus 1 over 14. So that is, so I write it again. I have cosine v dv. Actually, dv is du over 2. Here I will have 28. It was 14 and comes to from here, it's now 28. And then cosine v dv. Now I know the formula. What is it, guys? That is the sine v, right? So final u over 14 minus, I will have sine v over 28 plus c. Of course, it's not the final answer. I have to make necessary. Now u is 7x, okay? If I write here 7x, I need more space here. Okay, if u is 7, where is it? U is 7x. 7x over 14 will be x over 2. Okay, and minus sine v. V is 2u, right, guys? And u is 7x. So v is 2 times 7x, which is 14x. I have sine 14x over 28 plus c. So this is the final answer for the second question. We can write it, oh, we can use this one, guys, here. Yeah, I just checked the answer and it is maybe more clear. So we can use this one. Yeah, so this is sine 14x. I can write it as, well, 2 sine 7x and cosine 7x. And 7x over 14. And there's a question, wouldn't it be 1 over 14 times, which would make it be 1 over 7? Where it is, okay. So that will be, we will have, guys, x over 2 minus, from here, so I write it here. This one is 2 sine 7x cosine 7x. And I simplify this 2 and 28. It will be 1 over 14. I have over 14 sine 7x cosine 7x. I can write it as equal denominators. I just try to get the same answer like in the answer sheet. It is, guys, 7x minus sine 7x cosine 7x over all over 14 plus c. Yes, this is the final answer. This is the final simplest answer. Let's see. All right, now question number 3. We have complete this square. Guys, what was it? Do you remember? Complete the square. So here we are going to need it, right? And what do we have here? We already have a square here. I mean, square of a parenthesis. Let me write it. So x squared plus 4x plus 6. How can I write it as? It is, I see here the x squared plus 4x plus 4, and then plus 2. Okay, then this can be written as x plus 2 parenthesis squared plus that 2. That 2 I can write as square of square root. You may ask why? Why do we need to have it like that? Because, attention, this trinomial under the square root, right guys? Actually, I'm working with square root of now, what do I have? X plus 2 squared plus root 2 squared. And wow, where we may use it, where we can see it. We can see it in a right triangle. Yes, guys, in a right triangle. What do I mean? In a right triangle, this may be the hypotenuse. If the sides are x plus 2, sides of a right triangle, and one side is square root of 2, then the hypotenuse will be x plus 2 squared plus root 2 squared. So what? Why do we need to show these numbers as length of a right triangle? Because in a right triangle, we have trigonometry. So here, the ratios of the sides give us what, guys? Something. If I take this angle theta, okay? From here, I can write sine theta, cosine theta, or tangent theta. So what is tangent theta here? Tangent is x plus 2 over root 2. All right. So here, what do we have, guys? We have x, right? And here we have, from here, this actually will be, this is the hypotenuse in a right triangle, and we can use tangent theta and, or the other trigonometric ratios. All right, so guys, here, after finding tangent theta is x plus 2 over root 2, we get x, so x plus 2 is root 2 tangent 2, x is root 2 tangent theta minus 2, and dx is root 2 second squared theta d theta. And now I have to make these substitutions in the question. I have, you see it? Okay. So I have what, guys? I have x here, right? So that x, so I have to change this one to okay. So guys, here we have what? Where's my highlighter? So the x is root 2 tangent theta minus 2. Here we have. So that is x. We have dx, and we found dx here. Here it is. Okay. Then we have to find this one, square root of x squared plus 4x plus 6. And we know this is equivalent to this one. And we have to write it here, but we cannot write it like this. We have to write with theta. sine, cosine, tangent, cotangent, something else. What we know, let's write here, what we know, guys, secant theta here is equal to what? It is hypotenuse over adjacent side, okay? So that is root x plus 2 square plus root 2 square over root 2, okay? So what is, guys, this equal to? It's root 2 secant theta. I write it here in denominator. Root 2 secant theta. And do you see the simplifications here? This secant square and this secant theta we simplify. This root 2 and this root 2 we simplify. I don't need extra paper, okay? We take it. Okay. And here, guys, and then let's write what we have. So now we have root 2 tangent theta minus 2 secant theta d theta. I have this. And remember, yesterday we solved a similar question. You see, you remember when we had minus and we distributed the secant theta here. We will have root 2 tangent theta secant theta minus integral 2 secant theta d theta. So we have now two integrals. Oh, you don't see it, sorry. Okay. Clear, guys? So we have this one. And from here, now what we have here? We will have tangent theta, secant theta. What was the formula for this, guys? What was the integral of this? Do you remember? So we have equals. We have root 2 secant theta, because the derivative of tangent is tangent times secant, right? So tangent secant, the derivative of secant is tangent times secant. So integral of tangent times secant is secant, okay? And then minus 2, that 2 we would write here. And then it will be, so because of the same reason, it's ln of tangent, so secant theta plus, I think, right? Minus or plus, tangent theta and plus c. Wow. And the final thing, final answer we will have, it is root 2 secant theta. Here it is, guys. So we found the secant theta here. Square root of x plus 2 squared plus root 2 squared over root 2. By the way, they will cancel out each other. 2 times ln. So secant theta, it's this one again plus tangent theta. Tangent theta is here. So this plus this, ln of, yes, I have. So the denominator is root 2. Denominator is root 2. I have square root of x plus 2 squared plus root 2 squared plus x plus 2, and then plus c. Then we have Okay. So we have this one, guys. √3. Sorry, √2. Okay. And then the final answer is this. Let's see here. So √x² plus 4x plus 6. Yeah, when we open it, you see it? No. When we open it, we will have it. This one. And then minus 2 ln square root of plus x plus 2. Yes. And here, attention guys, here we had √2, but since it's division, it's a constant number, you know, ln a over b, we can write as, remember, ln a over something over √2, right? What is it? It's ln a minus ln √2, but that is a constant and c is a constant. So actually, I will not have in the final answer √2 here, okay? Logic is understandable because of that here, there is no √2. That √2 actually constant and it's written in C. Yes. So here the function is undefined at 1, but the integral from 0 to 1. And in this case, we have to use the limit notation, right? And how do we write it? You see it? Yes. So we have limit as b approach to 1. 1 from left side or right side? What do you think? It is 1 minus x. So if x, we approach to 1 from left side, there will be negative in square root. Oh, yeah, it's 8-degree root. So we should approach it from the right side. Since I must have a positive value in the square root or any even degree root. Okay, guys? And then, so we have what now? Not from 0 to 1, but 0 to b, this function. 8 root of 1 minus x. And I can write it as, you know, b approach to 1 plus 0 to b. I can write it as 1 minus x to the power of 1 over 8. Of course, I have dx all here. Yes, guys, I have dx all here. So that is limit as b approach to 1 from the right side. That is actually, if we take the integral, what will be the integral, guys? Yes, please. 1 over 8 plus 1 will be 9 over 8, yes? So I will have 1 minus x to the power of 1, wait a minute, 1 over 2. That is minus 1 over 8, sorry. Minus 1 over 8 plus 8 over 8, that is 7 over 8. And here I will have 8 over 7 from 0 to b. Any question here? So I just apply the integral formula. X to the n plus 1 over n plus 1. So over 7 over 8, but it will be coefficient 8 over 7. Okay. And it's equal to what here, guys? Then we just put the values here. And if b is b right here, so we have 8 over 7 and 8 over 7, 1 minus b to the power of 7 over 8, and then minus 8 over 7, 1 minus 0, 7 over 8. B approach to 1, so the value of this equal to 0. Here it's 1, 7 over 8, it is 1. It is negative 8 over 7. Negative or positive? Here we have negative 7, 8 over 7. Yes, guys. So guys, here it converges because we have a value, a rational value. It converges, diverges in case the result is infinite. Okay, so this is converges. And again, another integral, we have from 2 to infinite. And again, it's the improper integral. We have infinite. In case we have infinite, we have to use the limit, right? So what do I have? Limit of 6 over x to the power of 5. But the integral, not from 2 to the infinite, from 2 to the b, where b approaches to infinite. Okay, so dx. Well, I have this one, limit b approach to infinite, 6 from 2 to b, x to the power of minus 5 dx. Yes, guys, so I have to find this value. Limit b approach to infinite 6 times. So x to the power of minus 5. What is it, guys? X to the power of minus 4 over 4 from 2 to b. So we have, that's right, this one, because not for 6, for the x value. And then 6 times we have, of course, limit, we have limit b approach to infinite. That is b, well, I can write it in case of 1 over, negative 1 over 4 x to the power of 4. And negative 1, 4, b to the power of 4. And minus, so I will have plus 1 over 4, 4 times 2 to the power of 4. Okay, 4 times to the power of 4. I have this one. And now, since b approaches the infinite, the value of the first fraction equals 0. And we have 1 over 4 times 2 to the power of 4. And it will be, what is 2 to the power of 4? And we multiply by 6 this. So 6 over 4 times 16, which is 3 over 32. This is the answer. All right, guys. We solved this one, 3 over 32. I want to turn back to this question here. Attention, what I missed, this is a function, right? So 1 minus x. So when I apply the integral, I have to use u substitution here. Where u is 1 minus x, du should be equal to negative dx, right? And I will have that dx will be negative. It means here I will have minus. Here I will have minus. So that is minus here, and that makes the final answer positive. Okay, sorry for that. And now number 6. Number 6 is x cube ln x dx. Strange, huh? Here it is. Okay. Here we are going to use integral by parts. Okay. And if uv du, all right, uv du dv. What we are going to select as u and what we are going to select as u dv. So guys, u will be here, L and X. If u is ln x, it means x cube dx will be dv. And if x cube dx is dv, the v will be, if we take integral of both sides, we will have x to the 4 over 4, and du is, of course, 1 over x dx. And so what do we have now? You see it? Yes. X cubed ln x is, so u v x to the 4 over 4. I write it like this. Minus integral v du. That is x to the 4 over 4 times 1 over x dx. Okay, look here. That is the answer why I select u as ln x, because the du is 1 over x and I have no ln, just the exponents of powers of x here in this integral. So I have x over 4 ln x over 4. How can I write this, guys? This can be written as 1 over 4 integral x cubed dx. Yes, it can be written as this one. And if we calculate that integral, it is, so we have minus 1 over, so this is what? So x to the power of 4 over 4, we will have 1 over 16, 4 times 4 is 16, x to the 4 plus c. And so, yes, just we organize the final answer. We may write it as, so we have x to the 4 common and 1 over 4 common. We can take 1 over 16 as common fraction and x to the 4. So we will have 4 ln x minus 1 plus c. This will be the final answer.